You've heard it a million times, the Big Bang. But what if I told you, there is no bang in the Big Bang theory, and we actually have no idea what banged, or why? Let's unravel one of the biggest misconceptions in science, right now. When you hear Big Bang, you probably picture this. A giant fireball exploding into a dark, empty space, launching stars and planets like cosmic confetti, right? Well, that's totally wrong. The Big Bang wasn't an explosion in space, it was the sudden expansion of space itself. There wasn't a kaboom in the void. Space was the thing expanding, everywhere, all at once. So what does the Big Bang theory explain? Not the bang itself, not the beginning, it explains the aftermath. What the universe did after it started expanding. It tells us that space is stretching, galaxies are zooming apart, and everything was once hot and dense, like insanely hot. Like the entire universe was a soup of energy hot. And here's the kicker. The Big Bang theory doesn't tell us why the universe began expanding. It doesn't explain the spark, the trigger, the real bang. What happened at time zero or before that, we don't know. Our physics breaks down, our equations freak out, it's like trying to divide by zero. The universe just says, nope. Scientists have ideas though. Quantum fluctuations, a bouncing universe, infinite multiverse, but none of these are confirmed. We don't even know if before the Big Bang makes sense, because time itself might have started with the Big Bang. The name Big Bang was actually a sarcastic joke. It was coined by a scientist named Fred Hoyle, who didn't even believe in it. He said Big Bang to mock the idea on the radio, and somehow, the name stuck. But now it's part of science history, even if it sounds like a Michael Bay movie. So next time someone says, the Big Bang created the universe, you can say, actually the Big Bang theory describes what happened after the universe started expanding, but not what caused it. It's like walking into a movie 10 minutes late. We can figure out the plot, but we miss the opening scene. Here comes the question, could the Fourier transform explain the reason of the bang behind the Big Bang? Ever heard of the Fourier transform and thought, wait, is that some kind of math wizardry? Don't worry, today we're breaking it down super simple style. No equations, no headache, just clarity. Let's go. First, imagine sound, like my voice. It travels through the air as a wave, a wiggly line. Some waves are slow and deep, like a bass drum. Some are fast and sharp, like a whistle. That wiggle speed is called frequency. It's how many times the wave wiggles per second. The higher the frequency, the higher the pitch. Now here's the fun part. Real-world sounds, like music or voices, are usually a mix of lots of different frequencies mashed together. But what if we could take that complex sound and figure out what frequencies are inside it, like turning a smoothie back into fruits? That's exactly what the Fourier transform does. It's a mathematical magic trick that takes a signal in time, like a sound wave, and tells you what frequencies are hiding inside it. Instead of seeing the sound over time, we now see which notes are there and how strong each one is. Fourier transforms are everywhere. In audio editing to clean up sound, in radios to tune into stations, in MRI machines to see inside your body, even in earthquakes, to understand the planet's deep rumbles. The crazy idea, almost any signal, no matter how weird, can be built by adding together simple waves. Fourier transform just figures out which ones to use and how much of each. It's like Lego for waves. So that's the Fourier transform. A way to see the secret frequencies hiding inside the chaos. It's math, but it's also music and science. The Big Bang theory predicts that all matter, time, and space began at an incredibly tiny compact state about 13.8 billion years ago. This initial state was a hot, dense, uniform soup of particles that filled space uniformly and was expanding rapidly. The scientists' observations of the movements of galaxies tell us that the universe is expanding at an accelerated rate. We have three main possible scenarios for how our universe is expected to end: the Big Freeze, the Big Crunch, and the Big Rip. The answer mainly depends on whether the force of gravity will win over the repulsive force expanding the universe, also known as dark energy, or the other way around. We are not sure yet which scenario will happen. The Big Freeze is expected to occur if the repulsive force wins over gravity. In that case, the expansion of the universe will not continue accelerating. Still, the universe will keep getting bigger, galaxies will separate, and stars and planets will move away from each other. The light they emit is expected to be redshifted to long wavelengths with very low energies. The universe is expected to become darker and colder, approaching a frozen state known as the heat death of the universe. The Big Crunch is expected to happen if the force of gravity wins over the repulsive force. In that case, reversing the universe's expansion, galaxies are expected to start rushing toward each other, leading to a stronger gravitational pull. Space would get tighter and temperatures are expected to rise, leading to an extremely dense, hot, and compact universe comparable to the state that preceded the Big Bang. One of the proposals introduced in the book The Big Defreeze of the Universe by Mohammad Hasan Algarhy is that our universe is expected to end the same way it started. We are not sure whether it will be the Big Freeze, the Big Rip, or the Big Crunch. The Big Defreeze is the idea proposed in this book as the scenario that happened at the beginning of the universe preceding cosmic inflation. The idea of the Big Defreeze is compatible, at least partially, with any of these scenarios, which is explained in further detail in the book. The book suggests a potential mechanism that could be referred to as the Big Defreeze, which could potentially explain what preceded inflation and the Big Bang. It could also potentially explain the actual bang of the Big Bang. Additionally, the book goes a step before the proposed Big Defreeze to use an analogy called the straight line analogy, which could also explain the driver of the Big Defreeze mechanism. The straight line analogy considers that our universe, or even multiverse, has a one-dimensional representation of reality in the form of a straight line. This analogy is based on the holographic principle, cosmic inflation, the landscape of string theory, topological manifolds, and manifold bundles. Suppose you consider the two-dimensional data and the three-dimensional data as two versions of reality or two reconstructions of the same reality. Then why do we not have a third version or the third reconstruction of reality in one dimension represented in a straight line? The analogy goes that we have a straight line as a one-dimensional representation of reality, and a tiny fluctuation happened on that straight line without affecting its geometry. This fluctuation was then projected on another space, forming the identity stem wave of the universe, ISW. Fluctuations and interactions started happening to form an ISW crystal. The book proposes that when all matters, even if they were not bosons or ideal gases, are shattered to their elementary particles, they form Bose-Einstein condensates. These matter waves started fluctuating, forming what is referred to as the identity stem waves until the winding frequency of helium's ISW caused the symmetry breaking of the ISW crystal, leading to the Big Bang and inflation. The book also addresses what could be referred to as the fermions problem. If all matters, even if they were not a boson or ideal gas, got smashed and shattered to their elementary particles. For example, let's consider iron shuttered to its elementary particles, and these elementary particles, or more accurately fluctuations of waves, started cooling down to degrees close to absolute zero, forming Bose-Einstein condensates. This BC or quantum wave would act as the blueprint or the identity stem wave of this matter. The frequencies of these identity stem waves, ISWs, are comparable to the temperature at which they form BC. The Big Defreeze book suggests using the Fourier transformation to test and measure the mechanism of forming the ISWs as spikes or fluctuations. It indicates that for the ISWs of all matter, the winding frequency is comparable to the ISW's frequency except for helium. The winding frequency is expected to be 299,789,000, 12 times the frequency of helium's ISW, which suggests a symmetry-breaking mechanism. This mechanism breaks the symmetry of the supersymmetrical crystal, leading to an explosion or a big bang with a value comparable to the speed of light. This proposed mechanism could help us understand the time frame of forming identity stem waves of all elements. These identity stem waves can lead to what can be referred to as the Big Defreeze grand spectrum, from where we can determine the identity stem waves of all elementary particles and how they were born. A suggested methodology for experimental validation would be shuttering particles of two periodic table elements in the cold atom lab and observing the reactions, including the potential formation of two identity stem waves and how they react. Was the universe in a heat-death state before inflation and the Big Bang, comparable to what will happen in the Big Freeze scenario? Actually, at this phase there was no heat yet. There was no energy yet. So, probably we should call it a preheat state rather than a heat-death state. The Fourier transform will take it from here. The reason is that the Fourier transform would be our mathematical machine to decompose all the frequencies of information scrambled in that straight line and the supersymmetrical crystal. Additionally, if we worked it out the other way around, it could explain how this information was composed in the first place. At least for now, this will apply to the ISWs, the identity stem waves of our supersymmetrical crystal. The Fourier transform would help us understand how these ISWs were composed and coded in the first place. The first identity stem wave ISW would be our first signal with a given frequency of 10 to the power of -5. It is just a number for the purpose of the analogy. At this phase, time and space are one thing, so we just represent them by a number 10 to the power of -5. Since we have a given frequency for our ISW, our mathematical machine will start treating it differently. Let's graph this frequency at a finite portion of spacetime. Then take this graph and wrap it up around a circle. It could be considered as a rotating vector where the length of each point in spacetime is equal to the height of that graph for that spacetime, which would be equal to 10 to the power of -5 in our case here. High points of the graph correspond to a greater distance from the origin, and low points end up closer to the origin. So moving forward, 10 to the power of -5 units of spacetime would correspond to a single rotation around the circle. So here we have two different frequencies at play. The frequency of our identity stem wave ISW, which is 10 to the -5, and then separately, is the frequency with which we wrap the graph around the circle, which could be half of the rotation per spacetime unit. The winding frequency at this phase matches the frequency of our signal, 10 to the -5. All the high points on the graph happen on the right side of the circle, and all of the low points happen on the left. Remember that the identity stem wave ISW is the BC or quantum wave of the smashed and shattered elementary particle. So as the first ISW starts to fluctuate, having a frequency and winding, this would create energy or heat and stimulate the creation or formation of other ISWs, which will have different frequencies and start winding. Here a center of mass would start forming. As we add more frequencies and the graph winds up differently, that center of mass kind of wobbles around a bit. And for most of the winding frequencies, The peaks and the valleys are all spaced out around the circle, in such a way that the center of mass stays pretty close to the origin. It could get complicated, though when the sum of the winding frequencies is equal to the sum of the signal frequencies, the center of mass is expected to move far to the right. If we plot it on a graph, it will look like a spike. We will want to keep track of where the center of mass is for each winding frequency. When a certain frequency persists for a long time, then the magnitude of the Fourier transform at that frequency is scaled up to more and more. The longer that signal persists, the larger the value of the Fourier transform at that frequency. For other frequencies, even if you increase it by a bit, this is cancelled out by the fact that for longer time intervals, you are giving the wound-up graph more of a chance to balance itself around the circle. The frequencies of these identity stem waves ISWs are comparable to the temperature at which they form BC. The Big Defreeze of the Universe book suggests that for the ISWs of all matter, the winding frequency is comparable to the ISW's frequency except for helium. The winding frequency is expected to be 299,789,000, 12 times the frequency of helium's ISW, which suggests a symmetry-breaking mechanism. This is a mechanism that breaks the symmetry of the supersymmetrical crystal, leading to an explosion or a big bang with a value comparable to the speed of light. Remember that the velocity of the identity stem wave of helium is determined by its temperature. So in conclusion, the book The Big Defreeze of the Universe suggests using the Fourier transform to understand the symmetry-breaking mechanism of the ISW crystal, which could be the reason behind the bang of the Big Bang. The frequencies of these identity stem waves ISWs are comparable to the temperature at which they form BC. The Big Defreeze of the Universe book suggests using the Fourier transformation to test and measure the mechanism of forming the ISWs as spikes or fluctuations. It suggests that for the ISWs of all matter, the winding frequency is comparable to the ISW's frequency, except for helium. The winding frequency is expected to be 299,789,000, 12 times the frequency of helium's ISW, which suggests a symmetry-breaking mechanism. This is a mechanism that breaks the symmetry of the supersymmetrical crystal, leading to an explosion or a big bang with a value comparable to the speed of light. The Fourier transform is a way to see the secret frequencies hiding inside the chaos. It's a mathematical trick that takes a signal in time, like a sound wave, and tells you what frequencies are hiding inside it. It can be used to tell what frequencies were hidden before the Big Bang and what frequency caused the bang of the Big Bang.